everyone, and thank you, Charles. I'm going to do about 10 minutes of this presentation, and I'm going to hand over to Jim, who's going to show you a little bit of what we've made and why. And I suppose my role in this is to give you a bit of context, because otherwise you'll just all be sat thinking, yeah, but can't you just do that using XQuery? What on earth were you thinking? So I'm going to give you a little bit of context. So the law and XML go back a long way. Charles Goldfarb trained as a lawyer, and in the late 60s, he was interested in processing legal documents, and off the back of that work came up with a generalized markup language through to SGML and today as XML. So there's a long connection between working with legal content and using and exploiting markup languages. And legislation.gov.uk, and I was the head of legislation services at the National Archives for the last few months. I've been the digital director, but this has been one of the things that I've spent a lot of my time working on with some of you. I think there's probably 4 or 5 of you who at some point or another in the last decade have intersected with this product. So legislation.gov.uk is the government's legislation website, and we manage our legislation data in XML. And if you've ever had the pleasure or misfortune of working with legislation data, you will realise that it's kind of unique as a content domain. It's particularly unique in the UK, where we have the dubious privilege of having a single statute book with 3 legal systems, 4 parliaments and assemblies, and 4 governments, all essentially modifying this single corpus of statute law. Now, some of what you're going to hear is a little bit the story of finally we worked out why we were making all of the effort and energy to manage our documents in XML. And a lot of the original motivation for using XML, and we run a MarkLogic database, and we have an application substantially architected by the terrific Jamie Tennyson, that uses XQuery and XSLT and Albion. A lot of the motivation for using XML was to give us the capability to do multi-format publishing. And we've not really, until quite recently, been able to exploit, for other purposes, for other reasons, some of the capability that that database gives us. And what you're going to hear is, and see, is how we've been taking forward trying to exploit that capability. Now, we've been working on a new service, which is not yet publicly available, which is called research.legislation.gov.uk. And we had the idea that the statute book as a system of law has been under-analysed. There's not much that's counted about legislation, and there's not much by way of abstractions that allow you to see what kinds of law are being passed and how's that changing over time. So we set out to design a service to encourage particularly academic researchers, and particularly legal academics, but also political scientists, people like that, to start to ask questions of the statute book as a whole system. And we got some funding from one of the research councils to build this thing. And our original proposition was that if we made available data and provided some tools for processing that data, and we described the methods for working with that data, we could encourage new types of research into legislation. And then we tested that concept with some users. And we found that, sure, we could provide data, tools, and methods, but if you are a legal academic, you can work out how to download the data, but you are a mighty, mighty, mighty long way from being able to do anything with it. And particularly when your data is pretty complicated, mixed, markup, XML, the type of which we have, the engineering effort that a researcher would have to go to, even with the data, in order to be able to quickly answer the kinds of questions that we imagine people wanting to pose, was beyond most of the people who we were trying to reach. So our target audience, academics but not computer scientists who have interesting questions that the statute book as a whole might answer. Now you can speculate what those questions might be. Things like how much of the law in the UK stems from our obligations to be members of the European Union. And you can look at when people try and answer those kinds of questions at the moment, and they're counting pages. So not very sophisticated way of answering a question like that. How many mistakes do government departments make in secondary legislation, and who's making the most mistakes? Or how many powers is Parliament giving the government to make new legislation? Or how many criminal offences are being created? Lots of these kinds of questions. So that's the first piece of motivation. Can we mediate access between specialist users who have difficult questions that they might want to ask and answer against legislation and our legislation XML database? That's the first piece of motivation for this piece of work. The second was a particular research question that we had of our own. So we had the idea that there were commonly occurring legal design solutions to commonly occurring policy problems, and that there was a missing layer of abstraction that you could have in the statute book. And we wanted to, so we had this idea, we talked to drafters of legislation, basically saying, when have you written the same law twice? And we found that indeed there are commonly occurring legal design solutions to commonly occurring policy problems. And we started to create a pattern language of these legal design solutions. So for example, the licensing pattern. The state wants to control an area of activity. It does that by making, doing that activity being a criminal offence. You give someone a power who can give a permission to do the activity, and then you, usually through issuing a licence, and you have some conditions around that power. So the supply of electricity. If you supply electricity, you commit an offence, unless there's someone who can give a power, who has a power to give you a licence, and then if you have the licence, you can now supply electricity, and there are some conditions associated with that. Identifying the patterns by talking to lawyers then leads you to say, well, how do you start to find them? And using regular full-text search makes that really difficult, because what you want to find are, say, parts of legislation where there's a section that creates an offence, and in the same part is a power given to someone to issue a licence. And you can see how you might start to have words or phrases that would give you a good clue as to this part of legislation might be an instance of the licensing pattern, but you can't express that kind of question very easily using regular search. Sure, you can do it using xQuery, but that's quite a lot of work. And that really provided the motivation for the thing that Jim's going to show, which is you could kind of look at it as a domain-specific query language. It's the facility, sort of inspired by the Lucene search extensions, to allow people to express richer searches that enable them to get the value of our structured documents without having to go to the time and trouble and effort and energy of learning XQuery.
Okay, so, good morning. I'm going to do this more as a demonstration, no slides. So I encourage you to interrupt me, maybe more than is the custom here. So long as we have time, I'd rather talk about what you want to talk about. This is a very austere interface, which I just built for my own testing. We're going to use it today because it's the beautiful site that you just saw is not quite ready, and you're into XML, so you don't really care about design. I don't either. So just, okay, so at the core, this is a search engine which will search for things that legislative documents that have the word banana in them. If you just type banana, you'll get banana. I'm going to focus on, I'm not really going to, this is not an introduction to the tool. I figure you want to talk about the structure of the documents, so I'm not going to spend time. Obviously, you can, if you care about case sensitivity, you can specify that. Word stemming is, we'll find plurals, and we'll find B and R if you search for is. And legislative documents are interesting because it's quite common for them to have parts of themselves which are intended to be inserted into other documents. So this act says, in this other act, remove section 1, and in its place add this chunk of text. And you may want to ignore those parts or search only within them. So that's an option that we gave. So you can look, the default is we don't care, you look anywhere, but you can exclude those amendments or search only within them. And one of these is much more difficult to implement than the others, and we'll talk about that when we get to the implementation stage. And finally, the two main endpoints to the API, there's a search, which is what we saw, which will give you a page of documents with snippets. But if you want to know the number of total documents that match your search, you can ask for this is slower, but there are 114 documents that have the word banana. Okay, we're going to get back to that later. So for the rest of the time, I want to talk about what can go in this box, and I'm going to try to put a range of concepts on the table, all which will grow, and if it works the way it should, they accumulate and they can all be used with the others. So the first, which will be common to you, is you can combine words with Boolean operators. This search will do what you expect it to do. This one should too. And this one should too. This is a search for a phrase. And a search for a phrase is really just a search for words that are in close proximity to one another, in fact, a very specific proximate relation to one another. And so we expose that too. If you want to look for two words that are within 10 words of one another, you can do that. This will find documents that have the words apple and banana within 10 words of another, in that order. We just noticed the other day that when apple and banana are mentioned together, banana usually comes first. That's one of the interesting insights that you can reveal. You can also do an unordered, if you used the square brackets instead of the rounded brackets, you could get an unordered proximity search. Okay, so The simple keyword searching, that's just done with, keyword indexes on the documents. But our documents, legislative documents, highly structured, and structure is very important, and it's fairly familiar to the people who are likely to be interested. So we let you target your keyword search to specific parts of the document or elements. So if you want to find documents that have the word banana in the title, you can do that. And long title is another sort of document level element. In other words, there's only going to be one in a document. And for certain elements in which it's only going to have one layer of text and atomic string, I'll give you the whole content with the highlighted terms. And these sorts of things can be combined with one another with all the Boolean operators we saw before, and they can also appear within the parentheses. I can show you all of these permutations, but if I do every time, then it's going to grow exponentially. So you could have long table, banana or apple, and subject, European Union. That's not a subject. But okay. So we can target elements like this and do keyword searches within them. Sometimes, however, the thing you want to target, so the examples I've shown you so far are going to occur only once in a document, but sometimes you're going to target things that will appear many times, like a paragraph. Paragraph it doesn't mean what it means in HTML. Here it means a section of the law. So if you want to target a paragraph, you'll get 10 documents, the first 10 documents, and for each document you'll get the paragraphs themselves and links to them. So in the Crossrail Act of 2008, there's only one paragraph that has the word banana in it. It's paragraph 10 of Schedule 6. And legislation.gov.uk has wonderful APIs, and you can link directly to a section of a law, and the query tool links, all of the parts are linked will let you fetch them. Hopefully the word banana appears in there somewhere. Yes?
Just from my understanding, maybe I didn't get it. So you need the structured data in an XML form.
Yes.
So, and legislation is nice because it already is structured data.
Very
However, do you have to transform it once to XML? And how do you did this? So I think there are a lot of data, and I think there should be some automatic conversion going on or something like that to get all the structured data.
Yeah, that's a really 3 decades of 1988. A part of government called HMSO makes its first SGML DTD, and that's probably a conversation to have offline of how the hell did we get all of our data into XML. And it wasn't pretty. We were many highways and byways. There was SGML. Would you believe that for the revised legislation, some of it was stored in Lisp? But hey, it was 1990. What were you supposed to do? So a long, long story of how the data arrived there. Excitingly, we're currently working on a browser-based drafting tool for legislation that allows you to author XML in the browser, which is using Grant Vertighini's XML editor, which is another conversation, but we're targeting capturing XML in the browser from the authors in future. so we can avail ourselves and put in the drafter's hands some of the capability that we have with the legislation.gov.uk API and the ability to be able to have point-in-time referencing of the documents and pull stuff back and so on and so on. But long story. For the purposes of this, let's just assume that all of that hard work's been done and you have an XML database with all of the documents in XML and lots of other things taken care of.
But a common workflow still is draft in Word and convert it to XML?
Yeah. Yeah.
Okay, let's see. So, right, these sorts of things can be combined with one another in all of the ways we've seen before. They can be combined with word proximity search. You could put, para. Well, I guess that's the next concept. They can be, not only can they be combined, but they can be nested to these structural targets. Obviously, our documents are trees, as you know better than I. So you can do, let's see, a part. Maybe you want to find a part that has a paragraph that has the word appeal and the word license. And also anywhere in the part there's the phrase Secretary of State. That should do what you expect, I think. And the nesting doesn't always mean the same thing, although so maybe you want parts with the word appeal in their heading. So we have word stemming on, so we find appeals too. In this case, heading means a direct child of the part, not any descendant that happens to be a heading. But in the previous query, when para is used, nested within a part, I assume you want parts that have paragraphs as a descendant at all, regardless of whether they're within chapters or cross headings or subchapters or anything like that. And this is a good time maybe to step back and talk about what's getting done and who's doing the work. There are three places in which the work can get done. It can be done by the database against its indexes. That's, of course, your preference. It's very fast. It can be done by the database, but you might want it to do something that it can't resolve by its indexes alone. But the database can do it for you, and that's your second choice, because if you're running on a cluster, it will parallelize that work for you nicely. And finally, there's some work which it won't do, and you have to do yourself as the application developer in your application code. And we've seen examples of all of that so far. So the first query, title, banana, that's a simple one that the database knows how to do. We don't have to open any documents to know which ones are going to match because we keep an element word index. And the database knows how to do that for you. If you do part, para, some word, then the database can do that for you too, but it has to do a little more work because it keeps an ancestor-descendant index, and it keeps an element word index. But it won't do words for every path, at least. So it can find all the just by its indexes. It knows which ones have paragraphs inside of parts and which ones have your word inside a paragraph. But it has to load the documents to confirm that the paragraph is in fact one of the paragraphs that was inside the part. But finally, this one is harder, and I have to do a little work myself because, we can talk about this if you want, but it just so happens that the way we need to build our queries at runtime dynamically MarkLogic won't let you, I think I'm right about this, MarkLogic won't let you specify a direct child path at that stage. So here we want only children. So the database will do everything I've done before. It will find for me all headings that are descendants of parts that have appeal in them, but I need to filter myself to make sure that I only have the headings that are direct children. That's not so complicated, but if there's anything hard about what I've done, it's for all the queries that you'll see, trying to identify as much of the work as possible that the database can do and passing that off. So here you want the most narrowly tailored over-inclusive query, which would be headings that are descendants at all. That the database can do for you very quickly, and then you filter. Which makes the not operator tricky because you can't just do not of the first stage and then not of the second stage. You'll throw out too much. Okay, so those are the basic sort of element searches that we do, because most of the elements in our documents are just free-form natural English text, but some are not. Some are dates and numbers, and for those you want to do different things. So for these scalar types, we allow range queries with quantitative operators. You can search for documents with certain years, and you'll just get those. And you can do greater than or less than, and you can combine them with and equal to, not equal to. We're running a little long, so I'm going to not show you those things. Those are done with range indexes. So MarkLogic will let you order a query by anything that you've constructed a range index for. So you can now, anything that you can search for in this way, dates and numbers, you can order your query by. So you can search for the word banana and order by equals year, and you'll get them in the oldest to the newest. And if you put negative year, you'll get them newest to oldest. So we use a lot of, this is, we welcome feedback about our syntax. We use phrases, keywords that you're familiar with, and they don't mean exactly what we know they should mean, but we're trying to create a language for the layman that harnesses as much of the power as we can, as simply as possible. Ordering. You can do multiple layers of ordering. I'm not going to show that to you. You could order by year, and then within the year, you could order by something else. Okay, a little bit more about counting. So we've seen that you can count all the documents with the word banana in them. But John wanted to be able to count other things too, not just documents. So you can count almost anything that you would want to count, so long as you're willing to wait for it. The double ampersand is just means the same as and count schedules and total paragraphs. So, of all the documents that have the word banana in them, there are this many schedules and this many total paragraphs. That maybe is not the most useful query, but you get the idea. So maybe more interesting would be these documents have types. You probably don't work with legislation. That means statutory instruments in the UK. So maybe you want to know how many statutory instruments in the UK, and year is greater than 2010, and year is 2015.
Can I do my Europixel?
Yeah. I don't know why that's taking so long. The dangers of a live demo. Oh, it worked.
There's been a big argument about this. But the answer is 17,794 paragraphs of, so these are enactments, so they're regulations or articles in UK statutory instruments made by the government, by the coalition, since, more or less, since 2010 to 2015. You can put the exact dates in, and you can then start to subdivide this. But it gives you a flavour for, as you move from apples, bananas into stuff that people really want to know, this allows you quite quickly to express questions to which people really want to know the answers. And you can exploit our XML data and not have to learn XQuery to be able to pose some of those questions.
I didn't think you were on that side of that issue. One quick thing, if your query targets a structural element, something that can appear more than once in the document, you can also count the number of those things. This case, it's counting paragraphs, because that's what you searched for. Okay, so real quickly, now we've been counting, but you can also count when you search. So if you just search, hopefully this will do what you expect. It'll give you a page of documents that match the query, and for each document, it will have counted what you asked it to count. And you can ask for multiple counters, and you can count almost anything that you can count. Counting is done at runtime, after the document is loaded. It's very flexible. You can add new counters easily, but it's slow. I mean, you count them. You load the document, and you count the element. Okay. So, two last ideas, and then we'll go. These computed values, you can also, we decided to let you filter and order by them too, even though they're not stored values like the ones like the range queries we did before. So these are going to be slow, and in the case of order by, extremely slow, because you have to count your value for every document that matches your query. But our design decisions basically has been the only alternative is to not let you do it, so we'll let you do slow things. In the interest of time, I'm not going to show you that, but let's see. This is a pretty narrow query, so if we count by, let's count the total number of footnotes in these documents, and we'll order by equal negative total footnotes. This will, okay, it wasn't so long because the other restrictions were so narrow that, but it had to count the number of footnotes for all the matching documents and then give you the 10 matches. Okay, and last thing, so we've seen documents that have text, we've seen documents with scalar values, elements. There are some that we happen to know have just a fairly limited number of unique values, like department or subject. So for those, we let you group your accounts up by them, and you don't have to know the values. So if you want to know the number of footnotes in all of the matching documents, and you want these grouped by department, there you have it. So these are all of the department names. There are many more, but these are the only ones which appear in this subset of documents. I didn't show you the zeros. Is it an order by too? Yes, there's also order by. So you can group by and order by. Just a few fields can you group by: department, subject, signee, person who signed the document. And I think we'll end there because I only have 2 minutes, and I'd be delighted if there are 2 minutes worth of questions.
We definitely have time for questions.
In the back?
Yes, I'm afraid my question is not about XML side, but usability. You have built a very complex interface, and I wonder how much testing with intended users you have done so far, and what was your feedback?
You were the first test. No, we haven't done a lot yet.
We found, when we talked to the academic users that we were targeting this at, we found a bundle of people who were willing to, who essentially knew how to work Excel. So we would, and were happy with writing Excel type formulas. The legal academic or the political scientist or whatever, we're imagining would be willing to, particularly if we give them some examples, learn our syntax a little bit because they have some great questions. And we're going to give them some examples that they can then tweak and modify. We're looking not at a lay user, but someone who's reasonably well motivated, but doesn't have technology knowledge, but has domain knowledge. And that's our target audience.
Okay, but then for example, you are using as you select those para, which is your document element in XML, but not actually necessarily something is familiar to the domain user. Well, obviously people do abbreviate paragraph para, but someone might want to search for paragraph.
Actually, the element is not called paragraph. We picked para because we thought it would be easy. But we've tried to do what you say. They're actually not the names of the actual elements, but if we pick the wrong lay translation, then hopefully we'll learn that in testing and we can change it.
So it's quite hard. If you just take the names for numbered paragraphs in UK legislation are as follows: sections, clauses, regulations, articles, rules.
Regulation?
It's five different names across the different, depending on the type of document. I mean, so it's like, the paragraphs in schedules. Paragraph 1, regulation 1, section 1, clause 1. It's just a numbered, and we mean by here, we mean that.
Okay, so there's already this scope for confusion because this your para embraces all of these.
Yeah, we need to build a documentation.
In the back?
Yeah, just quickly following on from that. You've done the hard work here. It's not too difficult to put a front end, like a toolbar.
Right.
And all of those, you've got 5 sections, you select this and that, and you just add to that, because then that would increase your usability.
I think of it as a front end problem too, which is not really my problem. Ethan?
I was going to say the same thing, basically, that most of that query could be represented by some drop downs and stuff like that. Yeah.
Yeah,
We-
it's a trade-off, flexibility and usability.
I mean, we found that we actually have numismatists using Sparkle in conducting queries, but we've built an interface that probably handles 98% of what people want to do, and then the 2% of the really complex stuff that we can't possibly build an interface for, people will use the Sparkle endpoint to conduct those queries.
We were looking for a middle ground between those. I mean, we can build a simpler interface on top of this, and then of course there's XQuery below, and we were looking for a middle ground.
Was wondering about citations in text.
Citations?
Yes.
Let's see.
Would you be able to specifically, search for citations and group those, according
Right.
to what they refer, that sort of thing? Because that would be really useful.
Yes, I think you can. I've forgotten. I haven't done that query. Sometimes I forget the names of. Let's see. I know you can target. Let's see. They're all called. Let's see. There are annotations, but he doesn't mean annotations.
No.
He means a citation in. What's the name of that? What's the name of?
They're not all marked up.
These are all of the targets that I've done so far. I don't think that we did citation. Why not?
We did citation. They're not all marked up.
They're not all marked.
Sometimes because you'll go in this the 1999 Act in this Act means the blah 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 1999, and then you just see the 1999 Act, and because the and we've not marked up all the citations, so.
But many.
Yeah, citation counting is another thing that's really interesting to do.
That would be really
Right. I think there is a counter. I think here are the counters. Yeah, you can count them. Shall we try? Count total citations ordered by total. Let's just not do any of that.
That's really cool.
And you can do the group counting and all the other count. But I didn't do a text search by citation. I'll have to review some more to see if that would be useful, but it wouldn't be hard to add if it is useful.
Okay. Jim, John, thank you very much.
Thanks.